Hello, we want to show one of the properties of bounded, subsets of sets, and we have discussed the concept of the supremum in our earlier class. But in this video, we want to discuss the properties of infimum of subset of bounded sets. We are given is a subset AI and BI, where I is moving from 1 to infinity. It means that our I is a natural number, the bounded subset of real numbers. Then we are asked to show that the infimum of the sum of AI, that is the two of them, is greater than or equal to the infimum of the individual subsets. That is greater than or equal to the infimum of AI plus the infimum of BI. So let's start with this. Let's use some constant as the infimum. Let alpha be equals to the infimum of AI and beta be the infimum of BI. Don't forget our I move from 1, 2, 3, and so on. Okay. Now, adding them together, when we add the equation together, the first and the first one, second one, alpha plus beta be equals to the infimum of AI, where I is greater than or equals to 1, plus the infimum of BI, and also I is greater than or equals to 1. Now, this implies that, with this implies that, now, alpha and beta, alpha plus beta, is the infimum of the sum of AI plus BI. That's the meaning of that statement. Okay, if that happens, and we have said that alpha plus beta is the infimum. And before we can talk about alpha plus beta is, before we can talk about the infimum of a subset of a set, we must remember that a set that has the infimum must first of all have the lower bound. Okay? So, and we remember that the infimum of subset of real numbers is what? The greatest lower bound. So that implies that alpha plus beta, which we have been told that is not the infimum of the addition of the two sets or the two subsets, they happen to be what? They must be lower bound first. They must be lower bound before they can be what? The greatest lower bound. So in other words, now we can say this implies that it is clear that, thus it is clear that, let's write it there, thus we have that alpha plus beta is what? Is the lower bound, of the two. Of what? Of the sum of what? AI plus BI, with I greater than or equals to 1. Okay. And recall that. We have to recall this. Recall that. Every lower bound is usually, every lower bound is less than or equal to the infimum, because the infimum is what? The greatest lower bound. So every lower bound must be less than or equals to. This implies that since alpha plus beta is the lower bound, this implies that alpha plus beta, like from this statement, is less than or equals to what? The infimum of the AI plus BI. Yes. With I greater than or equals to 1. Okay? So you can finish it up here. With this statement now, it implies that alpha. So what now? What does alpha represent? Alpha represents from our assumption. So then Alpha represents the infimum of AI. So right, infimum of AI, I greater than equals to 1, plus infimum of BI, I greater than equals to 1, is now less than equal to the infimum of the sum of the two. I greater than equals to 1. So don't forget, we can, according to the concept of inequality, we can rewrite. So that implies then, no, we can't write then again. So finally, now rewriting this, you can see that the result we are looking for is already this. So finally, the infimum of AI, okay, I can even, without disturbing myself, this is what we actually wanted to show. This is what we actually wanted to show, which I have not cleaned on the board. So we have now, we have landed here, we have stopped here. So if we now interchange that this by bringing it on here and bringing it on there, you see that the infimum of the sum now will be greater than or equals to the inverse, which will give us this. To now give us this. So the proof is established. So we have this. We arrive at this. So if you write it, you have that value that is given for us to prove. So that is the end of the proof. You can see how simple this proof is. So if you like and enjoy this video, give it a thumb up, share, like, and comment. Bye.